So, yeah, hello and good day, everyone, and welcome to our final webinar for the year 2025 for Asia Pacific. And our last topic that we are going to discuss today is about the design of steel warehouse, which will be more focused on beam and anchoring workflow. So, my name is Gene. I'm product engineer for IDEA StatiCa, and I am your presenter for today. So I think most of you are all familiar with our webinar platform, which is the GoToWebinar platform. And just want to remind you also that this is a recorded webinar and you are muted by default. And also, I would like to encourage everyone, as we have a very limited time, to ask questions while I'm doing the demonstration. My colleague is here with me. He will be answering questions in the background. So please type your questions into the GoToWebinar applications. No? And should there be some questions that we are not able to answer during the webinar, we will answer it to you via email. So today's topic, I'm going to share a brief overview about the warehouse structure in order to have for you to have a general idea how it looks. And I'm also going to show the standard workflow using the global analytical model. In this case, I'm going to use StadPro software. And then after that, I will do the demonstration. So just to manage a little bit of your expectation, I just want to let you know that this webinar, again, is more focused on about simplifying your design workflow. So I will not be discussing a step-by-step modeling during this session. We have plenty of webinars for that, and that is for a different topic. So instead, we will be using predefined templates, or for example, you have your template that has been used by your company. We can make use of that as well. And of course, I will also demonstrate the baseplate anchoring to pedestal using detailed 3D from connection application, and how reinforcement in concrete can be considered to produce a more optimized design. And lastly, I will also discuss about the generation of customizable report, and as well as interpretation of the results. No? So before I go with my demonstration, let me just have a very quick poll. So what is your biggest pain points when designing steel connections? So you can select as many answers as you like, that suits you. So let me just launch the poll. I'm gonna launch it, and please select which one is your most biggest pain point that you usually encounter. I'll give you a couple of seconds to answer the poll or close it. Yeah, I think mostly has maybe 3 more seconds. I think mostly all of you have just voted. Okay, now I'm going to close the poll. And I'm going to share the poll. What's the results? Okay, so it seems that our main points is basically the design of anchoring. So it's more like, okay, also have some repetitive modeling of similar joints, managing load combinations correctly. Okay, this sounds like very fair to me as well. I've usually encountered the same thing. So thanks for voting for the poll. I'm gonna hide the poll now. So let me just continue with my demo in this case. Now, so just want to share with you a little bit of an overview about the structure. This is just a demonstration warehouse. As you can see from the isometric view, the total length is about 25 meters. The width of the structure is about 14 meters with a height of 6.5. The bay length is spaced about 5 meters in this case. So this is pretty straightforward. So let's get started to it. But before that, let me just show you the workflow of our process here. So regarding the workflow, we will export our structural analysis from STAAD model. Then we are going to export it to Checkbot application. And from there, we will directly sync it to our IDEA StatiCa Checkbot model. Checkbot actually acts as a data hub. This one bridges your global analytical model or CAD model with connection applications. No? It gathers everything into one place where you can view, organize, and also check your connections. And once we have imported our model to Checkbot, we're going to open it and design the connections using connection application. In connection application, this is where we open our joints and do the application of manufacturing operations. And once we did that, we can also do both calculations. And in the calculations, should we find something different, like for example, we can, when we check there is for anchoring, there's some failures, then that's the time we need to make use of the detailed 3D to further verify the anchoring itself for the concrete block. So that's basically it. And let me just go through the demonstration in this case. So I will now close my webcam. And I will close my slide as well. So here, as mentioned, I'm using STAAD Pro software. I have this one already analyzed, and this has already been designed. So I'm just going to go to the geometry. I can also run the analysis again to make sure that everything is okay. There, okay. Now after analysis, I will export this directly to IDEA StatiCa Checkbot. So what I can do, I just select, I want to make use of a geometry cursor right here. You have the options basically, if, for example, you have a very large project and you can also, you have the possibility to select only a portion of it or for example, just this way over here. But for this example, since we have a kind of like a small project, I can just simply select everything. No? It's up to you whether you want everything or not. In this example, I'm just going to select it everything. Under utilities, I'm going to go to the tools and I'm going to export it using the plugin IDEA StatiCa Checkbot. So I'm going to click on this and all the information that is available from your global analytical model, in this case STAAD Pro, like the geometry, load combinations, it will be captured everything. So let's just wait for a few seconds when it's being synced. All right, it's running in the background. All right, there it is. Now, once we have this, the program will pop up and ask you to save it, and you also have to select the design code. So we have plenty of design codes over here. In this example, I'll just specifically make use of AISC. This is what is being used in the STAAD Pro model. I'm just going to use this. I'm going to choose also the right steel conditions and also the concrete conditions. So I'm just going to create. And once it is created, it will generate as well now the checkbot applications right here. So all we have to do is now click on connections to import. So here we have already pre-selected it over here. So all I have to do is just click it right from here, and it will import everything. So let's give it a few seconds while all the model has been imported. All right, there it is. All right, so now here you can see as what is shown here in our STAD Pro model, everything is also captured, no? And you can even see, for example, I want to see the loadings that has been applied. So what you have there from your STAD Pro is also copied into the checkbot application. Now this is very useful, especially if you are doing connection design, because it could lead to sometimes human error where you wrongfully assign incorrect loads, especially with the sign conventions. You might think, okay, this is positive moment or bending or negative moment. So this is very useful in this case. And you also have the possibility to see the bending internal forces diagram. No? So here I can also show, for example, here the axial forces, what you have from your global analytical model. I can show the bending moment just to see that everything has been captured correctly from your global analysis model. I can close it, disable that file. Now in STAAD Pro, we see that all the members are actually segmented into different joints. So for example, right here, the raster is actually divided into how many segments. But in actual fact, when you construct this is actually 1 unit in here. So in Checkbot, you have the possibility to merge this member into 1 unit right here. So all you have to do is click. I click on merge from here. I'll just select the first and the last so that everything will be merged. I can do the same thing as well right there. It will be merged. And we have to do that for the other stuff right here. For example, here in the column, I want this column to be as 1 unit as well, so I can just click on merge over there. And that's the thing, because we are using STAAD Pro. But some programs, for example, like Robot or RFM or perhaps the tabs, you can have 1 single unit about there, but it's just different in STAAD Pro. So we have to do that, all of it, basically, but I do not want to show everything how I do that, because it's pretty much straightforward and the process is the same. So in actual fact, I have prepared already a merge model for you guys, so that you don't have to wait for me looking at the merge model. So here, for example, everything has been merged. So let me just select one part over there. And for example, I want to look over there that these are all merged, no? But there's one more options that I would like to highlight to you guys, is that for some instance, in STAAD Pro, some offsets are not properly applied. Like for example, here for this purlin over here. So in Checkbot, you have the options to offset this thing right there. So if you see this multiple design members in selection over here, you can click this part right here, and I can say I want to select specific area. And I also select this specific area over here. And the same thing, I'm going to select this part. And same here as well. So once I have that, all of this has already been selected. So I'll go back to the view. Now I can, from the insertion point, I can select basically, I want to put it at the top. So I can just say, okay, from there, I want to go to the top. And this will be aligned according to your selection. So you don't have to do it one by one. If in case this offset is not done in your global analytical model. Right, while it is being offset, you can see that from the program, it's already changes automatically from there based on that insertion point that we have added. Now from here, we are already ready to do some analysis on the connection or design the connection itself. So there are many connections available right here, and you can see that it's already grouped into different groups of connections. This is based on the topology and on the cross section that is being used. So for example, here you see group 1. This is basically at this part right here, which say our pedestal or something. And if I go to group 3, and this is basically grouped according to each joints. So the same thing we can do this all that part right there. So what if we want to design, let's say, okay, I want to design this specific part right here. Under which group is this? No, so this is, I think this is group. This is group 6. So let's say I want to open group 6. So you see, group 6 is for chevron bracing, the joint for this bracing over here. So I'm just gonna click on this group right here, and you will see that. Just want to emphasize before I do something. Let me open this reference connections for group 6. Okay, while it's opening in the background, just wait for a few seconds. All right, it's now opening. All right, here it is. Now it's open. So, okay. So it looks like this one. Now I want to say about here is that we can apply load effects basically. So here, this is by default, I have put it in calculate load extremes, which helps us a little bit simplify the process of calculation and identifying the most critical load case. From here, you can do that. And if I close this thing, you can also do that the same thing from here. No? So if I enable calculate load extremes from here, it will apply from the rest of the group. So one group will identify which critical load case will be applied in each and every connection. So here, for example, joint 72, there are 7 critical loads, and for node 69, there are only 2 critical load effects. So this actually will help us save some time doing the calculation itself. No, so you don't have to run every single load combinations just to identify which one is the most critical load. So the program will help you identify it so that it would save you some time. No? Now going back, I will apply some connections right here. As I mentioned, I will make use of some specific templates. Or for example, like I mentioned earlier, if you have some company templates from your organizations that you always make use of that specific connections, if you have the same project over and over again, you can make that available from your company itself. So now I open that once more. I can go click on propose. Once I propose, I can basically select. So here I have number of predefined templates over here. You see, you can basically select from during the installation. Yeah, there is a predefined templates, and if you have some company templates, it will appear also here. And if you have some personal templates, it will also appear from here. So here I can say I can select a number of specific connections, but I will select this one right here. I'm going to click on OK. And basically the connection is already applied. So what I can do, I can basically calculate it from here on this case, but I don't want to do that. All I have to do is click on save. But instead of doing it manually every single nodes, I can basically just do a bulk calculations over here. So I can calculate everything from this group right here. If I hit on calculate, of course, this will calculate everything from that specific group. And the good thing about this program right here is that you don't need to wait for this calculation to finish. You can also make use of, let's say, for example, I want to do another design. So for example, here, I want to select this apex over here, the roof apex. So I think this is, I don't know, okay, this is group number 10. So under group number 10, I can also, okay, let's do it from here. I can just click on calculate load extremes, and the program will help us identify load extremes. So from there, I will just click on open reference. Okay, so it's now calculating the back. It's now opening the background. Let's just wait for a few seconds. This will take a few seconds to open the whole connections. All right, here it is. Okay, so now that we have added the load effects, critical load effects selection, so you can see that there are a number of load combinations right here, but only two are selected, which the program considered as critical. So from here, I can also select one of my templates available. So all I have to do is click on propose. And again, I have numbers, plenty of connections available right here. I can select which one is one. So from here, okay, let me say I just want to select this part over here, and I can apply the connections right there. Okay. Okay. So I select the wrong template. Let me delete that. So you have the possibility to delete that if you see that there is something wrong with the template that you are using. So here I'm gonna click on propose again. Let's say here or this one, and it's all added right there. All right. So from here I can also click on save and close the connection. So from there again I can hit both calculate and then click on calculate all. So again, we are telling the program to run the calculation. So from here at the bottom, you can see that the number of connections that is being calculated. And the status of the calculations. So you will see what is going on during the calculation process. So now that we have those three joints, let's say we have to put in some base plate anchorings. No, so we have from here. Let's say we want to do this specific connections of the warehouse that we want to design. So I think this one is under code. I think this is group 2. Okay, this is group 2. Under group 2, I can just click on directly open reference connection. See, group 6 is already calculating in the background. Now, the best thing about this, while you are doing every single group both calculate in the background, is that you do all you design all the connections, you analyze. Say, for example, you're doing it in the morning. Once you hit analyze everything, you go for your lunch. When you come back for your lunch, your design is already finished. So it saves us a little bit of time, basically. So here I have here the column and the bracing area of our connection. So from here, again, I want to make use of the templates that we have. And of course, this is a base plate. There are plenty of base plates available right here that we can make use of. The rest are from predefined. Also, some are from my personal templates. Here, I can make use of this template right here and then apply this part over here. All I have to do is click on OK. Everything's all right. You can even change the parameters if you like. So for example, I want to change the parameters here. So here, say, for example, I have here 16. So instead of 16, I'm going to put that 20 mm thickness, just an example. And from there, it will automatically apply also when you change it from here and click on save. Those changes that we have made, it will be automatically applied to the rest of the connections. So you change only from your reference connection, but once you have changed that, the child connections will follow that specific changes that you have as well. So from here, again, I can click on calculate so that my calculations will go through. Here we can see that our calculations process is about 22% already. So, and we can do the same thing over and over again. So this is basically the exact procedure of the entire design process for designing every connections from Checkbot applications. Like now you can see already with that process, it's actually more efficient and time saving perhaps on our part, so that you don't have to manually go open every single connections from every single groups. No. So instead of doing one by one analysis and design, you are designing it according to groups. So it's much faster, quicker, and more efficient in that case. So here, I don't have to model everything instead, but I have here an example of the everything that has been completely analyzed for you. So all of the connections has been completely analyzed right here. You can see that from the green box, but we have some red box here, which is, okay, this is basically our anchors. So from here, so every group from here, you can see it's all under green mark, which means that it is calculated satisfactorily. But from here, we have some issues with this specific group, which is the anchors, which is in this part. And if we go through that joints, we can see that under this area over here, you can see that, okay, it is completely analyzed, but except for the anchorings. Anchors here, you have utilized by what, 600, okay, 659%, and the rest as well. You can even go one by one and identify, for example, here, okay, 800%. I think this one is the most I have identified this node as the most critical out of all this group, which is I have 1,200% overutilized just for the anchorings. Now, we all know that when we design the anchors, um, the in the connection application, the design is actually plain concrete or unreinforced concrete. So what we can do here, I will open this joint. Once I click on open, I will have that. We will investigate that what is going on. So we just go through. All right, this is the node that we have. So as you can see, everything has been completely analyzed, 100%. We don't have any issues with the bolts. We don't have any issues with the welds, but we have some issues with the anchors. No, so if I just go directly to the anchors, I can basically have a look at what is going on from there. So if I just let me just expand this thing right here. Okay, I'll just give it a few seconds while the program is. Okay, there you go. Okay, there's too many calculations in the background. So if I just expand this a little bit more, so I can see that, okay, out of all these anchors, there are 8 anchors over there. My maximum utilization is right here. The bind, right? I will open this right here. I go to the drop-down list, right-click from this calculation so that I can see what is going on from our structure, and we will find out what is going on. From here, we have here the calculation. So if I go here at anchor tensile resistance, I have 200, but my actual is only 38, so that's fine. But here, this is where our problem comes in. So we have some issues with concrete breakout resistance of anchor intentions. You see from here, we have our capacity is only 50, but we have 200 over kilonewton. And if I go down, here you can see that under anchor breakout resistance, you have 400. And for the interaction, that this is where our 1,200% overutilized here. So you have 12.1, which is greater than required 1 only. So if I just now that we know what is going on, I can close the thing. And now this gives us to consider using the detailed 3D application. I will apply reinforcement to the concrete block instead now, because we all know the design of the anchors right here does not consider reinforcement. So how to do that? If we want to consider reinforcement, here we have to click on RC check. From RC check, it will export everything right over here now. So we save that stuff over. Wait, okay, let me just save it somewhere. You know what? Let me just save it from the desktop. So N19 anchoring. All right, and click on save, and it will be saved. All right, just give it a few seconds while it is opening the background. Okay. All right, it's coming. Okay, here it is now. It's open. So here, what we have from the initial model that we have, which is this one. Once we exported it, Detail 3D will read all these informations that we have from our connection application. As you can see from the loadings, their loads are also captured from there. So from there, you can see that the loads are automatically incorporated into our model. What is going on is that the program asks you to provide some reinforcement into your model in this case. But before that, we need to make sure that our program our structure from in Detail 3D is correct. So we all know for a fact that this is a pedestal, and a pedestal needs to be connected into a foundation, for example, a footing or a pile cap or something. So we need to make some adjustment into our supports. So for example, we have here in this support right here, by default, this compressions only spring support is actually activated. But since this reinforcement right here has to go through directly to our foundation, I'm going to deactivate this options over here. Now from here, I will apply some reinforcement already in this case. So from here, let's say just go to rebar assembly. From rebar assembly, I can now right there. Okay, it is here. So let's just close this down. So under here, I want to make some adjustment. I want to use that of diameter 16, for example. So I want to make use of user input 16 mm diameter. And for the grade, let's say I want to make use of grade 40 reinforcement. For my reinforcement, okay. And of course, I will do some adjustment to the reinforcement. So here, I want to make use of the surface number 2. So from here, surface number 2, and put that reinforcement over here. Oops, I need to change this to definition of bar shape on more edges. So I forgot to put that in. So let's say I change it back to surface number 2. And I need to put my bent bars over here. So we have some edges. We need to reference our reinforcement according to the edges. So here, edge 1 and 2. Here I have 2, 3, and 4. So instead of 1 and 2, I will put 2 space 3 space 4. And I have my reinforcement, something like that. So, and as I mentioned, I need to have this continuous all the way to the foundation. I'm going to make use of this anchorage type at the beginning, continuous bar. The same goes here to the anchorage type at the end. Now you will see that, okay, we have some arrows reflected over here that this reinforcement is actually going all the way to the ground. I will make some surface base cover, let's say 40 mm surface cover, so that I can move slightly above it. Number of layers to, let's say, for example, 5. Upstream, so I need to make some adjustment here. So it's 1 and 5. Now I have 5 reinforcement. I can do the same thing, but let me say I want to make some adjustment on my spacing. Here, the concrete cover here, I need to make that 40. So each cover, I need to make some adjustment. So because the default is actually 20 mm that we have set. So instead of 20, let me change that to 40. But I want to change. I want to maintain that to the top. So top is maintained. So I have 40, 20, and 40. All right. Now I'm going to copy that specific reinforcement just at the, and I will change it to. Now once that we copy it, I will change the surface instead of 2. I'll just change it to 1. So 1, I now have like that. But in this case, let me just say only three numbers. And let's change this to 160. Right, let me change this to 150 for spacing. Now I have that reinforcement, and of course 16, and I have 20, so I will change the spacing here to, let's say, 36, because 16. All right, now I have made that simple adjustment. Now I can make use of some stirrups perhaps now, or column or confinement ties. I can apply here. Let's say I want to make, instead of 16, I want to use 10. So let me just go through. In this case, I will make use of surface number 6. So number 6, I'm going to make use of that. And 2, I'm going to change the edge surface 1, 2, 3, and 4. Now I have that. I'm going to make use of bend anchorage type. But my anchors will be bend. Now I have that stuff. Course, surface cover 50. And spacing to say 50, slightly more confined because of our very high concrete breakout. So let's say I want to put 9 over there. Okay. Okay, I need to make some adjustment instead of, oops, sorry, it should be 30 now. So 30, now I have my reinforcement already applied. Of course, from here, we can now run calculate now. So I can hit calculate from there. So to save us a little bit of time, I have already prepared for you the calculations over here. So as you can imagine, previously we have a failure anchors like 1,200% utilized, but after applying the reinforcement, you can see that it's actually everything is passing. So we can go to check tab. Under the check tab, we can investigate further as well. You see, this is the stress flow. You can also increase this, the scale if you want to see more. Let's say I want to make it to 3. This can become bigger, right? And under strength, I can also see the principal stresses of the concrete. And as I can see, if I, okay, show the mesh, here you can see, but you can only see it from the outside. But what about the inside? The good thing about this detail 3D is you can create sections. For example, here I created different sections just to see what is happening inside the concrete. And you can see this is principal stresses as well. So if I can also select number of sections that I have already created, but you can also create one as well. So here I have created 3, and you have there. Right. Now going to reinforcement, you can see the utilization also for the reinforcement itself. And we can see it from the bottom, we have here 98%. And if I go to anchor, also this is the most utilized anchor that we have. And if I move to anchorage, so under reinforcement, under anchorage, this is also, right, if I go to this part right here, you see these are the most stresses on the anchorage for the reinforcement right there. No? So you can see that the bond stress check right here. You can also select what is the bond stress on every specific reinforcement. And if you go to anchor, so these are, if you go same thing, you can see it from here. It's not much. Then go to limits. So you can see that this is about 34.2% right over here. Now that we have investigated everything and it is completely verified, we can actually go directly to the report. So from the report, you can basically apply some parameters here, whatever you want. You can also add some of your, for example, you want to add some options or some pictures into your models, like what I have here. I have added here some pictures. So you can actually click on this one and you can add the same thing as well. That is an options for you. Say if you want to show when you try to uh, show to your let's say for the checking engineers that which part are you checking. This image right here is quite useful for the if you put some pictures on it. So what I can do, I can generate the report from there, because we already know that it is completely verified. Going back to the, I call it model. Let me just click on that part. We have open. So here we all know already that even though this is not passing here, but in actual fact, when we verified it into detail 3D, we already know that this is actually passing once we consider the reinforcement of your concrete block. So here, what we can do is basically print out every single report from each and every connections over here. But to do that, it requires some time. If you do that, every single joints, open the joint, print out the report, again open another joint, print out the report. That is pretty much time consuming. But the good thing is, in Checkbot, you have here the option report from here. And once you hit on the report tab, it will basically, you can select which part you wanted to print out, basically. So if I go, so for example, on project info, you can put your info over here. You want the author, you can write it over there, and under software info, you can deactivate or deactivate this one, activate or deactivate. And under user paragraph, the one I mentioned earlier, this is also possible. You can also add some pictures out of it. No? Oops, wait, why it's not showing? All right, so now that, okay, now I press something that is not correct. Wait. Okay, so let me just generate, in this case, I should have added the, it's not showing. All right, let me generate this part. Once we have generated that part, okay. This should look into the report right here, no? This is how it looks like when the report is generated. So you can see I've selected only a few groups that I want to include. So here, for example, I selected group 2, group 6, group 14, and group 15. But you can select, if you want, you can select everything. No? But in this demonstration, I only specifically selected 4 groups in this case. Here you can see that under this group results, anchors are actually not okay in the status, but once we have verified that in detail, it's also okay already. And the one that I mentioned that I've added into the photos, this is what the photos I mentioned. You can add it into the report itself. And once you are satisfied with it, you can hit any kind of file extension. You can click on PDF. And should you, for example, if you want to fully customize it according to your company standard, you want to make use of your own letterhead, you can also make use of document file and try to prepare from there. So example, here, this is the document file that I've exported. So you can actually modify it according to your likings. And also, if I have the PDF file, I also have this kind of information right there. So all of those code checks that we have under taken so far in Checkbot is fully integrated, and we can see that everything is code checked correctly according to the standards. So yeah, so that's basically the demonstration about the workflow from BIM link to StatPro, and then from there it goes to detailed 3D for the consideration of reinforcement in the anchoring. So let me just go back to my slides in this case. Before I go, I want to ask another poll. So please help me, you select what's best answers for you. What would bring the biggest improvement to your connection workflow in this case? So you can also select multiple options. So let me just launch that one. You can vote. I give you a couple of minutes before doing that, before closing. Give you a few seconds. Okay, maybe 3 more seconds before I close the. Okay, some of you mostly voted a single environment. Okay. Okay, so I'm closing the poll now, and I will share the results. So most of you say it would bring more improvement if a single environment connecting all of the above. So that's good to hear. And also automatic import of load combinations from global FA model. All right, that is kind of like a expected. So thanks for voting for the poll. So I'm gonna hide the poll right now. And of course, I would just want to, for that, I just want to go back to my slides, and I just want to give you some summary out of what we have discussed right here. So in Checkbot, of course, import connections geometry and forces from your global FEA or CAD model. You can instantly do that. So you don't need to retype or remodel itself. Automatic grouping of connections. Of course, this will eliminate number of hours or your repetitive task. And of course, you can start with standard templates, which you can make use of your system company as well. This would cut off modeling time for you. And also my favorite is you can analyze connection in bulk. So you only have a short period of time, and also optimize design of anchorings. And also customizable calculation report generations. Obviously, this can save you a lot of time, no? Instead of printing multiple connections at once. And most likely, above all, you can manage everything in one single applications. This will save you precious time of coordination. No? So yeah, that's basically it. So what to do now? You can actually download the latest version from our webpage. And if you need to upgrade, you can also do that. And if you do not have anything available yet, you may scan the QR code and fill up the form from our form. And if you fill up that, you will be also contacted. No? This is a good time because our partners are running some special conditions. So you might want to take or grab the opportunity to grab the best price of the program itself. No? So yeah, after the webinar, so again, I would like to thank you for your attendance today. So after the webinar, you will get to ask a very short survey, some for improvement or what topic you want to discuss next, what webinar you would like to see next. That will be added into the survey. And also there are some recordings that will be available from our web page and also from our YouTube channels. If you want to try our program IDEA StatiCa, you may also download a trial version for 14 days. And of course, there are plenty of documentations, tutorials, webinars. You can always go visit our support and learning page to find out more about it. So yeah, so basically, that's the end of my presentation. Again, I would like to thank you very much and enjoy the rest of the day. Bye-bye.